So another problem that can be posed under this differentiability section is when you're given a piecewise function in the following way. Let's say you have 3x squared minus 5x if x is greater or equal to 2. And then let's say we have ax minus 2a plus b if x is less than 2. So this means on the left side of 2, it's some kind of a line, and on the right side it's a problem. And where a and b are some constants, where a, b are some constants. Do you have a question on this? So if f of x is differentiable at x equal to 2, what are the values of a and b? So let's think about the solution. All right, what's the first condition for differentiability? Continuity, right? Remember those two conditions. The first condition is continuity. If you have a piecewise function and you have different definition before and after 2, continuous means what?
There's no breaks.
There are no breaks, meaning that their values should agree. I mean, if the value at 2 and value at 2 of this is different, then you'll have a jump discontinuity. It'll be broken, right? So because we need continuity, 3x squared minus 5x evaluated at x equal to 2 should agree with ax minus 2a plus b evaluated at x equal to 2. Okay, these two functions evaluated at 2 should agree if we don't want any jumps between the two graphs. Okay. So let's plug in 2, that's 12, minus 5, that's 7 here. And if I plug in 2, I will be getting just b. Because if x is 2, 2a minus 2a, they cancel each other and you get b. So b is equal to 7. Now, is that all? Does continuity mean differentiability? No. The other way is right. Differentiability means continuity. But continuity doesn't mean it's differentiable. You need to satisfy another condition. What's the other condition? What was the second condition? The left limit of the derivative is equal to each other. And the proper word for that is the left derivative should equal to the right derivative. That's what I was saying. Okay. So so the next solution should be because we need left derivative equal to the right derivative. What's the left derivative? It's this one, right? So I should have ax minus 2a plus b. If I differentiate that and plug it into x equal to 2, that will tell me the slope of the left side of 2, because that's the definition of the left side of 2 for this function. Right? Whereas on the right side, what do I have? 3x squared minus 5x, right? So if I differentiate this and plug in x equal to 2, I will be getting the slope of this function, which is the right side of 2. And what do we need? We need the two slopes to agree in order for the derivative to exist. Right? So I need them to agree. So let's try that. If I differentiate this, it's just a. These are constants, so it's gone, right? If you although these look scary, these are just constants. If you differentiate constants, what do you get? 0. So you only need to differentiate ax. Now a is just a constant multiple, so you pull it outside the derivative. So the only thing you differentiate is x. Derivative of x is 1. So what do you get on the left side? A. Now what do you get if you plug in x equal to 2 here? There's no x in there, so it doesn't matter what value x takes. So you can plug in any value of x and it will still be a. The left side is a constant function once you differentiate. So a is what you get, even after plugging in x equal to 2. It's different here. X equal to does matter. So let's differentiate this. This gives you 6x. This gives you minus 5. So 6x minus 5, where 2 is plugged in. What's that? 7. That's again 7. 12x minus 5, no, 6x minus 5 with 2 plugged in, 2 times 6 is 12, 12 minus 5 is 7. Okay, so this is just pure coincidence. I didn't mean to make them both equal to 7. But the answer is that A is 7 and B is 7.